In the next one, again, you look at this and think, before we do anything else, we've got a common factor. 7 fours are 28, so I can pull 7 out the front and leave an x, and because 7 fours are 28, it becomes minus 4x, and a plus 4 here. And again, I look at this and say, okay, look, if it's a perfect square, this will just be the square root of that there, x, the square root of this here, 2, but this is a plus and this is a minus, so what have we got to put there? Well, minus 2 by minus 2 is plus 4, and minus 2 is equal to minus 4. What was all that about? Well, just think about this for a minute. If you've got x minus 2, x minus 2, we get the first term by multiplying. There's your x squared. The next term is minus 2x and another minus 2x. Could write it that way if I wanted to. And then this multiplied by minus 2 by minus 2, which is plus 4. So that's where your minus 4 comes from, because it's minus 2 minus 2. And then your 4 is just by multiplying those two together. Alright, so very quickly looking through some of these examples. These typically just find the highest common factor. These ones are pretty straightforward. It's just a 3, pull the 3 out the front. There's a 5 in this one. There's a minus 6 in this one. Can you see all that? There's a 2x in this one. So we factorise using that method. Here, is it so obvious? We've got an 8 and a 4 and a 10. What's the common factor? Well, it's just 2. We can't use any other number. 4 is okay for these two, but not for this one. So 2 is the highest common factor. There's an m in every one of them, and the lowest m is this one here, m to the power of 1, so that will be the common factor. And the same with the n's. It's going to be, so it's going to be 2mn is what you're going to pull out the front, and whatever's left. So here's that problem worked out there, 2mn out the front, and 4 times that gives you 8mn. 2m squared times this gives you this, and so on. The next one here, these are difference of two squares. It's the same, using this pattern all the way through. This one's pretty easy. X squared goes to an x. 16, the root of that is 4, so it's just going to be x minus 4, x plus 4 will be that form. What about something like this though? We've got that here. Not on that page, must be on the next one. No. What is it? I. Oh, there it is. It still is something squared minus something else squared. So when I take the square root of that, I just get left with x minus 4. So here's like your a minus b and your a plus b. The first term is just what's in here, so I put x minus 4 and x minus 4. The next term is just what's here, so I put x plus 1 and x plus 1. Left them in the brackets because I don't want to make the mistake of forgetting that that minus applies to this number, x, and this one here, 1. So when I get rid of my brackets in the next step, I've done that. X minus 4 comes down, minus x minus 1. This one here I don't have that issue because it's a plus out the front. And then I can tidy up. The x is minus x and x just cancel, leaving me with minus 5. And in here I'm left with 2x, and minus 1 and 4 is minus 3. This one here says to factorise showing that they're perfect squares. Again, I'll use this fact that this one here is twice whatever the square root of this is. So looking at this one here, the square root of 9 is 3, so a is 3. If I multiply 3 by 2, do I get 6? See, multiplying by 3 by 2? Yeah, I do. So that's going to work out. That's a perfect square, and it's just going to be like here, x plus 3. This one here looks horrible, but if we pull out a common factor, 3 is a common factor in all of this. That reduces it somewhat. Let's go down and find it. There it is. So the common factor comes out. Then I'm left with this. Now if it's a perfect square, it's going to be the same. I'm going to have in the something, I'll leave the 3 there, this one here is going to be the square root of that, which is just x. This one here is going to be just the square root of this, which is 5y. It's going to be squared. I don't have to decide is it a plus or a minus. Well, since that's a plus and plus, it must be this, and there's my answer. So while I've put in these extra steps, really, you can see from here, put a 3 out the front. I'd probably write this out, but I should be able to go straight to this answer. Same story. They're just getting more complicated in their appearance, but it really is the same type of situation here. This squared, something squared minus something else squared gives you the 9s squared, gives you 3 s's. This here gives you 5t. That's it. And it's just difference of 2 squares. This one here is perhaps a little different. If we go down and find f. Here, it's just useful to use a substitution. You don't have to, but it gets very complicated otherwise. Can you see that if we say, look, let a equal, just anything like, equal x minus 1. So this I can replace with a, and this I can replace with a. So I end up with having, that voice you can hear is Miss Appleby. So here you have a squared plus 4a plus 4, and instead, that's just Miss Appleby you can hear. She's now gone all red, never mind. So we've got a plus 2 all squared, and once we've done that we can then substitute this back in and we end up back down here. So that's really the techniques that you use for working out factorisation. There's some more here, and I'll put these up a little bit later. So I hope you found that useful.